Hello there. I've been gone for a couple of months, so this is my first video on returning. We're gonna start doing some optics. We'll do geometric optics, like ray optics, and then we'll do some wave optics, and then we'll finish up with its relation with other kinds of wave phenomena. Okay, so in this is the first in the series. So we start very simply with a law of reflection problem. This is a very standard problem. You get this in almost every course you take. So here is a situation where the mirror is, this is mirror original position, and then it will be rotated to this position. A ray of light comes in, there's the incident ray, and when the mirror is in this position, the original position, then the ray, this reflected ray, this is when mirror is position M, and this is keeping this same. If you rotate the mirror, then this ray that's coming, original ray, it will now come in another direction. Let me call it R prime in the same notation, R prime. So this is when mirror is M prime. Okay, so if this angle is theta, the question is, what is this angle? Okay, so this is a very simple problem, and it's just a probably you know how to do it. So here is just reminding you that if this is a mirror and if the ray comes in like that, then the way we define angle of incidence reflection is we draw a 90 degrees to the mirror. So this is the reflecting surface, 90 degrees. This is called normal. Let's call this point O, and let's call this point P. And so when this ray goes in that direction, and if this angle is theta incidence, then this angle is called theta reflection, and theta incidence equal to theta reflection. And of course, by this construct, you can say this angle is also equal to that angle. But they are not called incidence and reflection, but they could be. But we're just going to use this common convention. So this should be the case, okay, whether the mirror is here or here. So let's see what happens. What happens in this diagram? Originally, the reflection. This is the normal. Let's use the letter N for this. When normal to M. And let's letter O here, and letter P here, and letter Q here. And this one, let's call it Q prime. So this angle is equal to this angle. So P O N equals to Q O N. And okay, so Q O N, right? Okay, so that's from the original position. This other position, the normal will be in that normal will be like that, so that will be 90 degrees. This angle should be same as that angle, because angle between these two surfaces and their normals, you could say this angle, if this is theta, this angle will be theta. You can convince yourself, you can draw it out, and you can, maybe I'll leave this an exercise for you. You can say this is M prime, O, N prime. So you can actually show that M, O, M prime must be equal to N, O, N prime. And I'll leave this as an exercise for you. It's not very difficult to do it. Okay, so just assume that, right? So now we got this out of the way. Well, let's try to write law for the rotated part. Okay, so rotated part will be P O n prime. P O n prime will be Q prime O n prime. And what we want to find out is if n O n prime equals theta, then what is Q O Q prime? Q O Q prime. So okay, so what do we need to do to get this? Well, there's several ways you can proceed. One way I like it is just isolate this angle on one side. So what we want is Q O Q prime, that angle, that just equal to, if I go from here to here minus where to here, right? So I go angle P O Q, take away angle P O Q prime. But if you look at P O Q, so if you look at this using this equality, you can see it can go to P O N plus N O Q, so it's going to be 2 times P O N angle. And similarly, go from P to Q prime, I can go to this plus the same amount of that, so 2 times P O N prime, that angle. So P O N minus P O N primes. So if I take 2 common, I have angle P O N minus angle P O N prime, right? Okay, so this is just the angle between this N O N prime. So this is 2 times angle N O N prime, and this angle is the angle it rotates, so 2 times theta. So the direction between this R prime and R, this is actually 2 theta. And the angle between the mirrors rotated M and M prime is theta. So if you rotate the mirror by theta, the direction in which the ray rotates, that direction rotates by 2 theta. So it's very a standard problem. I hope this is helpful. We'll do more problems in future videos. If you like this explanation, just try to subscribe to the channel, and also check out my website for all kinds of other problems and explanations. Okay, take care. Bye.